In the following video, let's take a look at the Fourier transform of f of t, where f of t is equal to e to the negative t multiplied by the unit step function. So what we do when we transform it, we go into the frequency domain. So it's going to be f of omega, and that's going to be equal to the integral from negative infinity to infinity of f of t multiplied by e to the negative j omega t dt. So plugging in f of t, we get the integral negative infinity to infinity of e to the negative t, u of t, e to the negative j omega t dt. What we can do with this unit step function, u of t equals 1 for t greater than or equal to 0, and it's 0 otherwise. This means we're allowed to remove a lot of the integration. So we're only going to be integrating now from 0 to infinity of e to the negative t multiplied by e to the negative j omega t dt, right? So what we can do now is factor out a t, or combine these two exponents. We get 0 to infinity of e to the negative t minus j omega t dt. And we can factor out a t now. We get the integral 0 to infinity e to the negative t multiplied by 1 plus j omega. This is dt. So if we integrate this, we get negative 1 over 1 plus j omega e to the negative t times 1 plus j omega. And if we evaluate that at the bounds, we get 0 to infinity. So negative 1 over 1 plus j omega times e to the negative infinity minus negative 1 over 1 plus j omega times e to the negative 0. This one's going to go to 1. This one's going to go to 0 because 1 over e to the infinity equals 0. So this term goes away, and these two minus signs become a plus sign, and we get 1 over 1 plus j omega. So what we found is that if we Fourier transform e to the negative t, we get 1 over 1 plus j omega. Cool.